Good afternoon, guys. This is Mr. Douglas coming to you for our last video of the year for geometry. So I hope everybody is excited. I know this is not the ideal way that we wanted to end the school year, but here we are. And congratulations to those of you that have, persevered and continued through to the end while we've done this. So just want to just say good job. A lot of you have done a lot of hard work, and I'm seeing it on your grades. So I'm just very thankful for you, and thankful for those that have put in the effort to do this. Some of you have not, but it's kind of the way this last 9 weeks shook out. But anyways, this will be our last video for our third period. And just want to say how much I've enjoyed this school year with you guys. This has been a fun class. We've had a lot of good classes, a lot of good days in geometry this year. And sorry we didn't get to see the whole thing through in person, but hopefully I will get to have some of you again later on as we move through maybe an Algebra 2 or liberal arts math or something like that. So I look forward to seeing some of you again in the future. And we'll go ahead and get started then. What we're going to do today is go over the Chapter 11 practice test, which is Form C, that you should be able to find on Canvas, and then going through Pearson, of course, to do it. So I'm going to go ahead and pull up that Form C. So what I've done here, this is going to be pretty much the same thing that we've done all of Chapter 11, is that this has already been pre-filled, and I'm going to show you how to come up with the answer that we got. And then whenever you feel comfortable enough, you can go ahead and pull up Form A and try that. Of course, that is the actual test. Now, once again, Form C is the practice test. So don't get confused with that. But we'll go ahead and get started. There's 11 questions, so it's not terribly long. And most of it, I think, you should be able to do fairly quickly. So we'll just go and get started and see how we do each one of these. So number 1 says a plane intersects the triangular prism below through points A, B, and C. So if you remember a plane that intersects anything, if you think about it, the easiest way to visualize this, within your mind or however you want to see it, is that a plane is essentially like a window. If you could picture a piece of glass that is going to be cutting through some of these shapes, that is probably going to be the easiest way, or at least it is for me, to visualize this in my head, what this should look like. So within this here, if we were to look at this triangular prism and we said we have a plane that intersects through points A, B, and C. All right, so we know that it's going to come down through that sheet of glass and it's going to hit A, it's going to hit point B, and then point C. All right, so that sheet of glass has to touch those 3 points. So if you notice that, now within a real 3D model, this would actually be shaded in, and you can see all that. But what shape is that looking like? Well, it's not a rectangle, not a hexagon, not a trapezoid. So within this one, it has to be a triangle. All right, so number 1 is a triangle because it hits those 3 points, A, B, and C. All right, and then moving on. Oh yeah, one more thing. If you want to, if you're having a hard time visualizing this, we did put a tool out whenever we shared the video with Ms. Funcannon on a lesson 11.1. There's a link that you can click on if you go back into Canvas, and that will take you to a website where you can actually plug some of these in if you're still having a hard time visualizing what that would look like. So that could help you guys out too. So question number 2. So this one says, match each solid to the space figure formed by rotating about the given axis of rotation. So within this, this is once again trying to visualize what these solids would look like. In part A, you're given a rectangle, all right? And within this rectangle, it says if you were to rotate this, rotating means going around this axis here. If you want to think about it as the y-axis, it's just spinning around in a 360. And if you think about it going up and down, this is eventually going to wind up creating, you're going to have a circle at the base and a circle at the bottom. And then, of course, your sides would be here and here. So what would that wind up looking like? Well, that would be a cylinder. All right, looking at B, what does B correspond with? Well, if you think about it, if B were to rotate around and you would have the same exact shape on this side, Well, you don't even really have to visualize that terribly far. That it's half of a sphere, which we call a hemisphere. And if you rotated that thing up and down and around, you would get a 3D model of a hemisphere. Now on part C down here, what does that correspond with? Well, that one is a cone. And even though this looks like a triangle right here, which it is, if it were to rotate once again 360 around that axis, you would wind up getting a cone that has a circle for the base. And if it went around and around and around, that's the only option you can come up with would be a cone. So that is number 2. And then number 3 says, a plane intersects the prism perpendicular to the base, intersecting opposite sides of the base. Which best describes the cross section? So in this one, we have to be careful. Remember, there was 2 words that we always have seen multiple times throughout this year, perpendicular and parallel. Well, if your base is up here, I'm going to highlight this. This is your base, or the top base at least. And of course, this would be your bottom base down here. So those are your bases. So if something were to be perpendicular, all right, remember that has to form a 90-degree angle. So our plane or the window pane, the piece of glass, wherever you want to picture it, that's going to be going through, has to form a 90-degree angle with the base, which means this is going to be going up and down. So I'm going to try to draw this in right here. So if you could imagine this being your window pane, all right, right there. So now we have hit a 90-degree because this is going to be straight up and down from the base. So this is formed at 90 degrees, which is perpendicular, and it touches the top and the bottom base. Well, looking at that, what does that look like? Does it look like a rectangle, a hexagon? Well, remember, a hexagon has to have how many sides? It has to have 6. So it's not a hexagon. Is it a trapezoid? No, a trapezoid only has 4 sides. But it has to have very particular sets to be a trapezoid, or I'm sorry, very particular criteria. It is not a trapezoid, and of course a triangle has 3 sides. So the only thing this could be is a rectangle. So just be careful with that. Now, if you wanted to flip the script on this and you said if this were not actually perpendicular but parallel, well, if it were parallel, it would be cut directly in the center of this shape. And what actually is the shape? Well, this shape happened to be a hexagon. So if this were parallel, then you would have a hexagon. But be careful with the reading of this and how it's asking the question, because that will definitely change your answer. So this one is a rectangle. All right, moving on to number 4. So number 4 says each hemisphere of a globe has a volume of 31,104 pi centimeters cubed. What is the radius of the globe? All right, so this is one of those problems where we're going to have to deconstruct it based on what the formula is for a hemisphere, and then just we're going to isolate and solve for the variable r. So if you guys remember, hopefully, if not, I would suggest getting out that formula sheet that we listed in Canvas, because that will help yet again on how to solve this. But the volume of a hemisphere is 2/3 pi times the radius cubed. All right, so all we have to do now is simply plug back in what this problem has given us. So the volume that says is 31,000, so 31,104 pi, and that is going to be equal to our formula. So 2/3 pi r cubed, and now we just need to solve for r. So one thing you can go ahead, and this will be pretty easy. We have a pi on each side, so if we go to divide it, those are just going to cancel each other out. So we can go ahead and make that easy. And then remember, if I want to get rid of 2/3, I need to multiply by the reciprocal to each side. So if I multiply both sides by 3/2, multiply by 3/2. All right, so let me plug that in and see what we get. So 31,104 times 3/2 is going to be 46,656. So that is 46 and then 656. And all of that equals the radius cubed. because this is gone, that's gone, and now that's gone. So remember, how do you get rid of a cubed exponent? Well, you're going to raise it to whatever will cancel it off, or not cancel it off, but whatever would offset it to just the number 1. So 3 times what would give you the number 1? Well, it's 1/3. So if I raise both sides to a power of 1/3, then that will give us what our radius is. So if I take 46,656 and then raise it to a power of 1/3, I would get R equals 36 centimeters. And remember, there's always, if you're confused on this when you get to the test, if you want to make sure what you did was right, well, simply plug it back in. If you plug 36 back into this R right here, then you should wind up with this same volume. If you don't, then there was an error somewhere. So hopefully that'll help you out whenever you work through this. Just plug it back in, and then you should get the right answer if you did it correctly. All right, so number 5. Number 5 says, assuming a soap bubble is a perfect sphere, what is the diameter of a bubble containing 500 cubic centimeters of air to the nearest tenth of a centimeter? All right, so once again, we are going to do what we just did. We're going to work backwards, except this time we're using the formula for the volume of a sphere, which was 4/3 pi r cubed. So volume of a sphere is 4/3 pi r cubed. So we're going to plug in, we know what the volume is. The volume is 500 because the problem tells us that. So we're going to substitute that value in for V. And then we're going to work backwards or deconstruct this in order to solve for R. All right, so at this point, a couple things you can do. I would go ahead and get rid of the fraction first. So if you multiply both sides by 3/4, that will get rid of the 4/3 on the right-hand side. So 500 times 3/4 is going to give you 375. So if I multiply both sides by 3/4, all right, well then these will cancel, and then you're going to be left with 375. And that equals pi r cubed. So next, still need to get r by itself, so divide both sides by pi. All right, so 375 divided by pi is going to be 119.366. So that's 119.366. And the reason I'm going out to the 1,000th place on this is just to make sure there's no error in my rounding. So when you do that, you're going to be set that equal to r cubed. And just as we saw last problem, if I raise both sides to a power of 1/3, that will isolate and get r completely by itself, which is what we're trying to do. So I'm going to raise this side to 1/3, and then I'm going to raise this side to 1/3. And remember, when I say raise, this is when you're going to use the XY button on your calculator, or the caret symbol, depending on what kind of calculator that you have. But if I take 119.366 and then I raise that to a power of 1/3, you're going to get 4.924. So R equals 4.924. Now, if you were to be done with this and you said, okay, I'm good, I found my radius, answer C, we're good to go. Well, be careful with that, because this problem is not actually asking what the radius is, it wants to know the diameter. But remember, if you know the radius, you can find the diameter, because the diameter is just 2 times the radius. So that answer times 2 is going to give you 9.847. So the diameter is actually the radius times 2, which is 9.847, which in this case corresponds to answer choice B. So not terribly hard, a couple steps, just solving for a missing variable and then multiplying that by 2 to get your answer. All right, so number 6. this says, which best compares the volumes of the two cylinders? All right, so this is another question, and we've seen this quite a bit in chapter 11, that has to deal with Cavalier's principle. And if you notice on this, remember the principle says as long as your base area was the same and your heights are the same, it doesn't matter if it's slanted, if it's straight vertical, horizontal, whenever you're comparing the two shapes, you're going to have the same volume. But within this one is a little unique that if you notice the radiuses or the radii are the same for A and B. The height on H is completely vertical, but the shape for shape B, the height is actually slanted. So if you notice this this depiction of the height right here is slanted. Now, if the height had come off and looked just like this one did, meaning that it was straight vertical when it indicated the height, then they would be the exact same. But because this one looks kind of crooked, that should be a sign to you that they are not the exact same. So because of that, this answer choice is C, which is the volume of cylinder B is less than the volume of cylinder A. All right, we don't know how much less. We're not asked to calculate it, but we do know that they're not going to be the same. All right, and we should know just simply by looking at it that cylinder B is not going to be any bigger than shape A, so it has to be letter C. All right, so once again, that goes back to Cavalier's principle. All right, so moving on to number 7. So number 7 says the volume of box A is 72. The volume of box A is twice the volume of box B. So what is the height of box B at point A? So this one kind of sounds confusing, but it's really not that bad. So remember, how do you find the volume of a cube or a box or a rectangular prism? It's all the same. The volume is length times width times height. So volume is length times width times height. So if I know that, I can just start plugging these in. And I know that the volume is 72. And these, it really doesn't matter which order you put these in. So I'll just say this is 3 times 4 times H. All right, well, 3 times 4 is 12. So 72 equals 12 times H. And if I want to get H by itself, you're going to divide both sides by 12. So H equals 6. So within this one, the height for A, or box A, is going to be 6. 3 times 4 times 6 is where I got 72. But the problem says that for that height, that is twice the volume of box B. So if I take 6 and divide it by 2, that should give me the height of box B, which just so happens to be 3. So on this one, does that make sense? Well, 3 times 4 is 12. 12 times 3 is 36. And is 36 half of 72? Yes, it is. So that is how we got answer choice D, which is 3 units. All right, so moving on to number 8. All right, number 8, if it'll load. Internet's being a little bit slow. Sorry guys, it'll come up here in just a second. Come on, internet. Sorry, guys, my internet has been in and out all day today. All right, maybe. Okay, well, we're back to the beginning of the test, but let me just jump ahead and get us back to question 8. All right, so question 8 says a stack of 1 dozen cookies of diameter 2.5 inches exactly fits in a cylindrical container of volume 14.726 cubic inches. What is the thickness of each cookie? All right, so there's a couple bits of information here that we're going to use to solve this problem. Number one, we know that we're dealing with a cylinder, so we need to know what is going to be the volume of a cylinder. Well, remember the volume of a cylinder is pi r squared times h. So that one is pi times r squared times h. All right, so with that, we're just going to start plugging in some of this information, and then we're going to work backwards to find out how thick is each cookie. All right, because essentially what we're going to be doing is we're going to solve and isolate the variable h for height, and then we're going to use that to find out how big is each cookie. So the volume is 14.726. All right, and that's going to be equal to pi. Now, what is my radius? Well, it says that the diameter of one cookie is 2.5 inches. And as we just said previously, the diameter is 2 times the radius. So if you take 2.5 and divide it by 2, you're going to get 1.25. All right, so this is going to be 1.25 squared times h. So now we can just work all this out. So you can go ahead and you could, if you want to, you can divide both sides by pi. All right, those will cancel. So 14.726 divided by pi is going to be 4.687. And that's going to equal 1.25 squared times h. All right, so 1.25 squared is 1.5625. So I'm going to divide both sides by that. 1.5625. 1.5625. All right, so these two are going to cancel out, and then 4.687 divided by 1.5625 is going to be 2.99968. So within this, if you just rounded this up, because this would round up, the height is simply equal to 3. All right, now here is the other part to this. This question says that there is a dozen cookies. So if you don't know this already, hopefully you do. How many units are in a dozen of anything? Whether a dozen means 12. So if you were to take 3, so I'm going to do this right here. So take 3 and divide it by 12. All right, and then what are you going to get? Well, 3 divided by 12 is simply going to be 0.25. So that means each cookie is 0.25 inches thick, and 12 of them together would give us our stack of 3 inches tall. So this question happened to be answer choice A. All right, so that's how you do number 8. All right, so moving on to number 9, a model of a tent is shown. What is the volume? So this is straightforward. This one, you just simply get the formula for the volume of a cone, which remember that is 1/3 pi r squared times h. So volume is 1/3 pi r squared times h. And then you just plug everything in. So volume is 1/3 times pi, and then what is your radius? Well, that's 3.4. So 3.4 squared times your height, which is 4.8. And then the rest of this, you just simply plug into a calculator. So if I do 1/3, all right, I'm gonna multiply that by pi, times my radius squared times my height. All right, and if you do that, you should wind up getting 58.1068, or I think this is going to round up to 58.107. So as long as you do it correctly, you should get answer choice B, which is 58.107 cubic feet. And that's how you do number 9. All right, moving on to number 10. Number 10 says a gym is investigating which paper cups to use for its water fountain. Which best compares the volumes of cup A to cup B? All right, so there's one thing we should notice right off the bat when you're comparing these. Obviously, shape or cone cup A, if you will, is going to be 2 times taller than cone B, but cone B is going to be 2 times wider at the base. Now, if you're thinking about it, which one would make more sense as to which one is bigger? Well, if you go back, let me redraw that again. So remember, the volume for a cone is 1/3 times pi r squared times the height. So on this one, which one would be the most important as to which variable grows the fastest? All right, because that's really going to give us our answer on this question. So if your height grows quicker, is that going to make it bigger? If your radius grows quicker, you know, what are we looking for? Well, if you notice on this one, the one that's always going to grow the fastest is the one that is exponential, which happens to be r squared. So it doesn't matter what you plug in. If your R is going to be bigger when you're comparing two shapes, then that's the one that's going to give you more volume, even if the height is not the same. So for instance, if you were to plug in, just hypothetical here, say you plugged in a unit measurement of 2 into the radius for A and B. I've already done the math on this ahead of time, but this is going to be roughly 16 cubic I don't know, cubic inches, cubic units, whatever. And this one would be 32. All right, so those are approximate figures. But the reasoning is because when you go to plug in 2 here for this R, well, 2 times 2 is 4, but 4 squared, remember your squared unit, is going to double that into 16. So 16 down here is going to be way bigger than just simply 4 over here. And because of that, which ones does this correspond with? The volume of B can definitely contain more than A. So within that, this answer choice should have been A. All right, and that's just a good rule of thumb whenever you're comparing cones or any 3D shape that has a circular base. Whenever you can double the radius, which is what happened from A to B, it will substantially or essentially double your volume. All right, and the reason is because the radius gets squared within the formula, which makes it grow bigger or faster than just simply doubling the height. So just keep that in mind whenever you go to solve this. This one is A. All right, so that was number 10, and moving on to our last question, which is number 11. Number 11 says, a pile of earth removed from an excavation is a cone measuring 12 feet high and 30 feet across its base. So what we have is a big cone. All right, and remember that's a big circular cone. So the height is 12 and the diameter is 30. So what is the radius? If your diameter is 30, well, that's going to be 15. So the first thing we need to do on this problem is find what is the volume of this actual cone that they have removed from the earth. So this is 1/3 times pi r squared times h. So within this problem, we can now substitute the values that they gave us. So remember, the radius here is going to be half of 30 because 30 is across the entire base and we only need half of that. So this is going to be 15 squared, and then multiply that by the height, and it said the height is 12. So that goes there. So now if you were to simply put this into your calculator, so 1/3 times pi times 15 squared and then times that by 12. All right, you're going to get 2827.4333. All right, so this is 28. All right, 27.433. All right, so that is cubic feet of dirt or earth or whatever it is that they're excavating. So the second part to this says, how many trips will it take to haul away the earth using a dump truck with a capacity of 9 cubic yards? All right, so this is the part of this question that makes it tricky. So essentially, we have a pile of dirt that is given to us in cubic feet, but we're going to remove that dirt in a vehicle that is measuring in cubic yards. All right, so what do we need to do? Well, we need to convert what we have down here into cubic yards. Well, how do you do that? Well, remember there's three feet in each cubic yard. All right. So, or I'm sorry, there's three feet to a yard. That's the conversion going back and forth. So if we were to, or if we know that, we can now go ahead and say, well, how many cubic feet are going to be within the dump truck? Well, we can go ahead. So 9 times 3 is going to be 27. So if we take the number that we just got and we divide that by 27, all right, then that's going to be 104.7197. All right, so what we've done, just to kind of recap us here so that we're not lost, we found the volume in cubic feet of this pile of earth, pile of dirt, and that's where we got this figure right here. All right, we're going to take that figure and we're going to convert it into the measurement of how it's going to be removed. And it's being removed by this dump truck. So the dump truck can haul 9 cubic yards, and how many feet are in that? Well, there is 27 feet within 9 cubic yards. So if I were to divide this figure by 27, this is where I wound up with 104.7197. All right, so the last thing that we're going to do is we're going to do one more final conversion. All right, so that is how many how many cubic yards are in this pile right here. All right, so the last thing we're going to do is divide this figure by 9, because that is going to be how many trips it takes to get rid of it all, assuming that the dump truck can take 9 cubic yards at one time. So if you were to simply divide that by 9, you're going to get 11.635. All right, so we got 11.635. So if that's the case, if you were to take 11 trips, would that completely haul away everything? No, there's still some left over. So round up to the next whole unit. So this particular answer up here is going to be 12 trips. So the answer to this problem is 12. All right, so that is number 11. All right, so let me go back. I want to recap this just in case there's still some confusion. So number 1 or whenever you're going to do this on test form A, number 1, you're going to find the volume of this, and you're going to use the volume of a cone, which is where we got this number right here. So from there, you're going to convert this into cubic yards. All right. So, and the reason that we're doing that is because we're going to come back and divide it by cubic yards to get our final answer. So once you find this in cubic feet, we're going to turn around and convert that by 27. And the reason it's 27 is because we're using this 9 right here. 9 times 3 is 27. And then you get 104.7197. So how many, if you were to convert 2827 cubic feet, then that is 104.7 cubic yards. All right, so once you do that, then you're going to convert that into the number of trips that it would take. And if you can take in one trip 9 cubic yards, then you would just divide this figure by 9, which is where we got this. And then you would essentially have to round that up to the next whole number to get your answer of 12. So I know that probably was a little bit confusing on that, because you have to convert into cubic feet into cubic yards, and then divide that number by however the capacity of the dump truck. So I know that was a little confusing, but as long as you follow those steps, that should get you the right answer. All right, so that is all of the tests. That is question 11, and that is how you do the practice test. So from here, all you guys have to do is complete question, I'm sorry, not question, Form A on the practice test, I'm sorry, on the real test, and then that's all you have to do essentially for the year. So once you guys have done that, then you are good to go. And for everybody that's done all the assignments, this is your last assignment. So once again, just want to say congratulations for making it to the end of this year. This is not how we at all predicted that this would turn out with the coronavirus. And I know this has definitely been frustrating at times, but good job for those that have stuck with it and done it. I'm very proud of you all. And like I said earlier, I look forward to hopefully being able to teach some of you again next year or the years to come for those that are freshmen. It's been a pleasure this year. It's been fun. I've enjoyed it. And if I don't see you before then, please stay safe, enjoy a good summer, and hopefully we'll be back to a normal schedule for the next school year. So that's it. Y'all have a good day, and we'll see you soon.